So firstly, thanks to the committee for the opportunity and the invitation to come across to the Mount today from Hamilton and talk to you about some work that I'm doing. We've just lost the input for the moment, but it'll come back. So as Rick said, I've spent a fair bit of time working in pasture genetics, and what I want to talk to you today about was really some work around how I believe genomics is about to, and is already in a couple of places, changing the way that pasture breeding's done, and at some of the challenges that I believe that you're likely to face when making choices about varieties in the near future. So I've termed my talk, and that's good timing, genomics in plant breeding. What's on the horizon, and how far away is that horizon? I know that people like myself who work in research get up every year and say, well, it's a few years out. But I did want to talk to you about where is the horizon. The other thing that I'd like to introduce today that won't be in my talk, but I'm happy to discuss, is I'm about to lead a research activity within the Dairy Futures CRC, which James mentioned the CRC before, and you know a little bit about it, which is a bit of a change for me, and it's not about developing these new technologies, but it's really a research program that's about understanding the value of these technologies and working with farmers to ensure that the technologies find their way onto farm and then the maximum value is captured from them on farm. So while I have the slides up, I'll make a start and see if that keeps them with me. So what I want to start with is talk a little bit about what is genomics. And we hear a little bit about, genomics and biotech as if it's a new big thing and it's going to change the way plant breeders think and the way everyone thinks. And what I'd like to make the point with this slide is that plant breeding has never been what I would call a conventional science. Plant breeders have used a whole range of tools which were the ones that were available to them at the time. So in pasture breeding, we see a few of these in terms of hybridisation between species, so some of the enhanced ryegrasses that are around which have some fescue in their genome. The use of polyploidy, which anyone who buys a tetraploid Italian ryegrass is buying the product of some pretty radical genetic manipulation, whereby somewhere in its history way back, a plant breeder has treated that plant with a chemical to cause the doubling of the number of chromosomes in the plant. So that's a pretty radical genetic change that you wouldn't want to do to a human being or another thing. So plant breeding has used some pretty radical technologies. The other thing is around mutation breeding, where again, chemical or radiation has been used to either knock out genes or cause a change of function. Not so widely used in the breeding of pastures, but in some other areas. The other thing I'd say about genomics is it's not just molecular markers, which is a science term for what we could call DNA fingerprinting. It's not only transgenesis, and again, transgenesis is the scientific term for genetic modification or GM. And it's not an alternative to plant breeding. It really is what is modern plant breeding. So I have a picture here of a dairy farmer with some tetraploid Italian ryegrass made into silage. So the result of some very, as I said, radical genetic manipulations. And so one of the things I say about genomics, it's a tool that plant breeders can use. And it's often said that the difference between men and boys is the price of their toys. Well, I'd say that the difference between a tradesman and a fool is the way you use your tools. And so in all these things, what we need to have is a suite of tools that allows scientists and breeders to target the right traits, the right outputs that are going to bring us benefit on farm. So what is on the horizon? So what I'd like to do in the talk is tell you a little bit about some of the things that are on the horizon with some time frames, and then go through a couple of specific examples of research that we did within the Victorian Department of Primary Industries, the Molecular Plant Breeding CRC, and now the Dairy Futures CRC. There are a range of new strains of endophyte that are being released, have been released, that have been used and developed using genomic technologies according to that suite I put up before. So, and particularly in terms of looking to confirm the absence of the toxin-producing genes in those endophytes, and I'll talk a little bit about that. We're just seeing now the start of DNA fingerprinting techniques to be developed in pastures, and I believe that you'll be seeing varieties that have benefited from that on farm within the next couple of years. And then, of course, there is the potential development of a range of genetically modified forages. And some of the ones that are advanced in the pipeline in terms of a research pipeline here are Roundup Ready Lucerne, which has been developed in the US. Whether that will be imported into Australia is another thing. Work that we have done developing white clover, which is resistant to a virus called alfalfa mosaic virus. And also some work around developing high quality grasses. So I'll touch on some of those examples. One of the things that's very important when we think about pasture genetics is the system in which the genetics need to go. And when I talk to producers about this, this is not normally a surprise for them. Interestingly, it usually is a bit more of a surprise for some young scientists who are going down a pipeline and don't always like to think that there are all these other things outside their control. So if we think about how a plant which goes onto farm, which we might have developed and might be marketed by PGG Wrightson or another company comes along, we can see that obviously the genotype or the genetics of the animal will have an impact, how well that animal utilises the pasture. Obviously the plant genetics have an impact, and also how those genetics impact with other plants. We know that very often pastures are not just the one species. Work around understanding population structure and the variability in those populations. If you plant out individual plants of perennial ryegrass cultivar, which we don't often see them, the range of variability that you see in those would be far greater than if you put your herd of cows out and measured them one by one. So plant breeding compared to animal breeding is a way back in terms of getting that consistency of performance. We see the average, but we don't often see on farm the individuals. Obviously, seasonal variation has a big impact here in Australia in the expression of the genetic potential of any pasture. I put this slide up. This is my farm south of Hamilton at Viaduct. The date is right. That's December pasture. That's a perennial ryegrass-based pasture. Wouldn't matter what genes I had in there for high digestibility, the forage quality is impacted in that year by the fact it didn't rain in October and November. This year I could have put a picture up with February and had green perennial ryegrass. So again, when I talk to colleagues in Europe about that, they don't believe that's a ryegrass-based pasture. They've never seen anything like it. And obviously management effects. Some of the first work that we were involved with, and we're very proud of, was in terms of using some of these genomic technologies to better develop novel endophyte strains. And the management of perennial ryegrass and its endophyte, I believe, is one of the big breakthroughs that's occurring and evolving as we are in Australia and New Zealand today. Again, for those that are not familiar, although I know most people are, the endophyte is a fungus which grows within the ryegrass plant. It causes a range of negative animal performance attributes. So these are examples of sheep with ryegrass staggers, which is caused by an alkaloid called lolitrum, and a range of positive effects, such as reduction of insect feeding due to other different compounds. Now, the way this association works, different endophytes will have the potential to produce different toxins. They interact with the grass, they interact with how the animals react to this, and with the environment. So it's a very complex association. We did some work to try and use DNA fingerprinting techniques to understand the genetic diversity of the endophyte and how it affects animal performance and the endophyte performance here in Australia. We're able to show that the endophytes clustered together based on their DNA fingerprint according to more or less to where they came from. But far more interestingly, we're able to attribute this genetic variation to the compounds that they produced. So down here, you have an example of a commercially available endophyte, AR1. It only produces the compound peramine, which is an insect deterrent. It doesn't produce lolitrum or ergovaline. The other thing that we did, we were excited by this and we thought, okay, we're going to go out there and find a whole range of endophytes that we will collect in Australia from old paddocks where there had not been a history of ryegrass staggers. And so we went out and we collected very broadly, but unfortunately what we found was that all those endophytes had the potential to produce these toxic compounds. So what we saw there was it was actually not the endophyte strain which was causing that more favourable performance. It was either the environment, the way the plants were experiencing stresses. They were all in the background of Victorian, so it wasn't so much the plant genetic background. So again, this really changed the way we were thinking about how to develop endophytes for Australia.